Hey everybody, how's it going? Today we're going to be working on a MacBook. Let's start up the stream and get started working on this MacBook. Are you all happy to be working on a MacBook with me? I hope you are. So we're going to figure out what's wrong with this MacBook over here. Just going to put it on the screen. By the way, I don't know which one of you bought this because I didn't even advertise it yet, but I was just adding random junk to my website since people are always talking about having merchandise. So on my site, I have this thing over here. Let's see, repair tools and parts. One of the subcategories is called memes and dreams. And one of the things here is a non-functional battery with my signature and a story. And somebody bought that, and I didn't think it was actually going to start selling because I didn't even think I made that public yet. But I wrote a 2-page story about one of my best friends who I haven't seen for 9 years just yesterday, and I signed it to sell along with the broken battery. Someone actually bought a broken battery to get a story that I wrote. But that will be shipping out on Tuesday. Okay, but back to the more important aspects over here. We are going to be working on a MacBook that doesn't work. So the first question that I asked myself is, what's wrong with this MacBook? Self? So we are going to turn on my power supply. We're going to turn on my multimeter. We're going to turn on some multimeter software and some power supply software, and we're going to get started fixing this board, if it is indeed a board problem. Remember, we don't want to assume that it's a board problem before confirming that it's not a parts problem or a user problem. Because let's face it, we're talking about Apple. Often, it will be a user problem. In the words of my first commercial landlord, it's probably something you guys did. We are going to plug this in, and we are going to turn it on, and we are going to see what amount of power it's taking, because I'm kind of curious how much power it's taking. And it seems like the fan is spinning, which means this probably already works. And it works, and it turns on. But does it stay on? Now, let's see what the customer's specific complaint was, since this computer is already turning on, and it's giving me a happy little chime. I'm going to read the customer complaint, and then we go from there. Let's load up the customer's ticket and see what their complaint is. So for this ticket, their complaint is literally nothing, because the person who works here did not put an issue description, so I have no idea what the fuck is wrong with it. And fortunately, they've already left. If they had not already left, I would have taken them. I would have tied them up. I would have put a gag in their mouth. I would have driven them down to Florida, and I would have put them into a pit of hungry, unfed rabid alligators and told them to never do this again. But they already left. Just took the plunge to start my own phone and laptop screen repair business in my hometown, and I've been... son of a... Well, I wish you the best of luck with your business. I hope that you do very well. Okay, let's see if it does charge. So I'm going to plug the battery in and see if the amperage goes up. And it appears that the amperage is not going up. The amperage is still stuck at 400, so it is indeed not charging. So we're going to try something different here. What I'd like to do is I'd like to see what the voltage is on PP-Bus G3 Hot, because remember, when the SMC has issues, we'll get 8.1 volts, and when it's working, we get 8.5. Perhaps that's the case here. Ah, now I see why you're not charging. You're not charging because if you charged, my battery would explode in my face. So what do you guys notice about PP-Bus G3 Hot being 17.5 volts? Does anything seem a little off to you there, that PP-Bus is 17.5 volts? PP-Bus G3 Hot is the main voltage rail for the computer. It's also going to be supplied by the battery if it's not supplied by the charger. So when the charger is plugged in, the charger is going to take 17 volts and turn it into 8 volts for PP-Bus G3 Hot. If the charger is not plugged in, PP-Bus G3 Hot will be taken from the battery. PP-Bus G3 Hot, when the charger is plugged in, is also going to go to the battery to allow the battery to charge. I'll show you that on the schematic that I'm going to put on the screen in a moment if Paul Daniels' software works, which today it's actually working very well. Must have said something nice about Paul Daniels it caught it. So let's get that on the screen right now so that you can see it and perhaps learn something. So we go over to U7100 and you take a look at how this circuit works. This is what's called a buck converter, and I will link to one of my older videos when I do the edited version of this video. I would suggest you watch it because I include lots of pictures that make it really easy to tell what's going on. So this over here is going to be the circuit that is responsible for making the 18 volts into 8 volts. So over here, you have 18 volts coming in from the charger, and it goes through this. This is reverse current protection. These are transistors. Transistors are only going, typically, you see this little diode over here? It's only going to let stuff go one way unless it has power going to the gate or not going to the gate, depending on the type of transistor. Whole idea here, you don't want your battery going through this and then through here and then charging your charger when your charger's not plugged in. I'm not sure if you've ever bought a really, really garbage 18650 battery for a flashlight. I don't know if you ever had this before, but you get like a really shitty cheap charger and you put the battery in, you plug it into the wall, the light turns on, and then when you unplug it from the wall, the light still fucking stays on because the battery is charging the charger and keeping the light on because there's no reverse current protection because it's a cheap piece of crap. A MacBook is a piece of crap in many ways, but it's not that much of a piece of crap. So you have something here called reverse current protection. So it's going to go through this transistor, then it's going to go through here. This is the current sensing section. The current sensing section is going to have a reading on the top and the bottom of this resistor. There's going to be a voltage over here, voltage over there. The difference in voltage between here and here is going to be directly proportional to the amount of amperage the system is using. This system is using more amperage, a bigger difference. System using less amperage, a smaller difference. That difference is going to be monitored by the ISL 6259 through R7121 and R7122, and it's going to allow it to tell how much amperage the system is using. If it thinks it's using too much, it turns everything off so that the machine does not turn on fire like my e-bike once did when I bought a battery from the wrong AliExpress vendor. This is a transistor. It's actually two. One transistor is going between 18 volts and PP bus, the other between PP bus and ground. This is a buck converter. The way a buck converter is going to work is it's going to take the 18 volts and try to turn it into 8. How do you take 18 volts and turn it into 8 efficiently? That's a great question. What you're going to do is you're going to split it up. So instead of having 18 volts go through all the time, you have 18 volts, turn off 0 volts. Turn on 18 volts, turn off 0 volts. When you mix 18, 0, 18, 0, 18, 0, it averages out to around 8 or 9. However, this is no good. Instead of having a nice kind of like, here, we're just going to push slowly, instead of like pushing comfortably to get something from point A to point B, you just punch it, and then you wait a second, and then punch it, and then you wait a second. The thing being punched is not going to appreciate that. If you're helping move someone who's in a wheelchair and you gently push them, that's fine. However, if you were to punch the back of the wheelchair as hard as you could each time, or smash the wheelchair with your car, you're going to make the wheelchair move forward, but the person in the wheelchair might not appreciate it so much. So what we have over here is a inductor. This is going to resist quick changes, so it's going to be more an average of 8.5, and then capacitors to ground, which is also going to smooth everything out. My iPad Pro battery expanded and leaked lithium, so let's hope I get a free replacement. There are a lot more details, though. Well, I wish you the best of luck getting your replacement, and hopefully it doesn't blow you up. So the coil over here is going to resist quick changes. It's like a slinky. It's not going to be good at dealing with quick changes. So it's going to kind of average everything out a little bit. And then you also have the capacitors to ground, so it's going to store those pulses, which winds up getting you, instead of 18 and 0, 18 and 0, just a nice smooth 8.5. However, if we're getting 18 volts all the time, what that means is that it's not actually switching. So on the schematic over here, you'll see Q7130, which is going to be doing the switching and sending that 18 volts from the charger to PP bus G3 hot over here. This is our PP bus. It's controlled by ISL 6259. It doesn't seem to be. It seems to be stuck in the on position all the time. Why is it stuck in the on position all the time? That's a great question. Now, what the system is smart enough to do, which again, I will give Apple credit where credit is due. This is good design. If this fails, instead of spending 18 volts of the battery, which is then going to wind up exploding, it says, wait a second, 18 volts on PP bus? No way. And this transistor closes. This is a transistor that sits between our PP bus G3 hot that we just created and the battery. This is the last line of defense. If this fails, you are now sending 18 volts to an 8-volt battery. It is not going to appreciate that, nor the testicles of the individual using that computer on their lap. But you don't have to worry about that anymore, because they call it a notebook, not a laptop, so that they can't get sued when it goes on fire and blows your balls off. So I don't really understand why they even bother including Q7155 there, because I'm sure they'd be fine without it. At this point, we're going to take the board out of the machine and see if there's any hints that tell us why this transistor is stuck. Is it a bad transistor? Is U7100 dead? Is there corrosion? Did something blow up? Do we have no hints, and then we just have to figure out which one it is by randomly guessing and replacing things? Well, we're about to find out. Are you excited? Because I'm excited. We are going to take a fine look at the ISL 6259 area. The ISL 6259 is the chip on the schematic that I showed you that's going to be responsible for controlling Q7130. This chip is available for purchase at store.rossmangroup.com. Soon, our website will actually work if you're using Firefox. That's right. I'm stupid enough to hire a web developer that for 2 years said he was working on a site and didn't. And when we found a new web designer, put together a site that works in every browser but Firefox. But by the end of the week, our site will even work in Firefox for no extra charge. That's going to be what allows it to work. I'm also going to take out the solid-state drive in the computer because I don't want the solid-state drive to experience any of the heating that's going to happen as I heat up the board while replacing components that are going to require lots of heat, like transistors that pass some of the main system power through them. We're going to take this machine and put it to the side, and I'm going to take the top of the case of the machine and put it over so that that SSD cannot fall out and get lost, causing the customer to lose their data and me to lose my job. Try to avoid losing the customer's solid-state drive. If you lose the customer's solid-state drive, they'll be very mad at you. It is very easy to do so in these machines. Organization is important. Now, the way that I would find U7100 if I were using the schematic and the board view software designed by Paul Daniels at pldaniels.com is I would click on the chip itself. But if I didn't know where the chip was, I would right-click on this over here. And when I right-click U7100, it will show me on the board view where U7100 is. Everybody, I want you to say thank you to Paul Daniels. Everybody say thank you to Mr. Paul Daniels for creating the software that makes my life easier and happier. Without Paul Daniels, this would be a much more angry stream. As you can see, we have corrosion. And the corrosion is right in this corner over here. You just turn the light up so you can see that a little better. You see that? That's what we call corrosion. Now, I'm kind of curious what it's on. So here is the way I figure out how to do my job. It's not by going to college. It's not by reading a gigantic 900-page book. It's not because I was born a genius. I see a system that has a problem. And then once I look it over and I figure out what the problem was, I store it in my brain in a database. So the next time I have that problem, I know that this problem is caused by this thing, or I know what the relation is between my problem and the signal that is corroded. So over here, it looks like charger phase is shorted to charger U-gate or ground. Let's just view that in the schematic and the board view. We have charger U-gate and charger phase shorted. Now, charger U-gate, if you take a look on the schematic, is going to be upper gate. Charger, upper gate. This is a transistor. This is 2 transistors in one. And the transistor is going to have a gate, a source, and a drain. The way the transistor works, if you watch my transistor video, which I will link to here in the edited version of the video, it's going to open when you send voltage to the gate. If you're using an N-channel transistor, when you send voltage to the gate, it will allow power to go through from the source to the drain. What do you think is going to happen when you take voltage and you constantly put it on the gate so it's always there? What's going to happen is instead of this transistor only opening, when the ISL 6259 decides I'm going to send power to the gate, it's going to open all the time because the power from the gate is going to be stuck. This over here, charger phase, is going to be always going to the gate, which means this transistor will always be open, which means it will always send 18 volts through. So it is no longer a switching power supply. It is a permanently on linear power supply, or go boom boom power supply. I'm going to clean off that corrosion and see if it changes our results. And depending on what it looks like, I might even replace the chip because I no longer trust it. There's one way to find out. Can you tell me what the T in MOSFET stands for, Deadeye? That's what I thought you... Now we are going to turn on the smaller iron. We're going to remove the corrosion. And what I want is for all of the corroded crap, as well as the old solder, to get stuck to my iron. I have an 820000165 that won't turn on. Whilst taking meter readings, that board suddenly had fan spin and now works. WTF. Welcome to my world, James. Welcome to my world. You probably have corrosion somewhere that you can't see. Look further. Here, we'll get the bottom of it as well. That is a nice, happily cleaned area. That is all the liquid damage that is necessary to damage a MacBook. Doesn't take much, now does it? Now I'm going to wait for that to cool off momentarily, and as I do, I'm going to sort out my desk a little bit, and perhaps read some of the Twitch comments. Did you get a message from Edson yet? I have not received a message from Edson, and I don't expect to. Anytime a company sends me something to review that they think is a slam dunk, hit out of the park, amazing product, and I wind up bringing it back to reality, it doesn't. It's always been the same pattern. I'm gonna wake up to a very awkward email on Tuesday about how I was using it wrong, or I missed something, or like, you know, you don't understand. This is the feature, blah blah. That's what always happens, and it's why I hate doing product reviews. I genuinely hate doing product reviews. If that happened to you, would you charge customer? What did you do? You got to figure out what you did. You did something. You got to figure out what you did. Stop asking about charging the customer before you figure out what you did. You're skipping ahead. You're skipping ahead to charging people. Like, don't skip ahead to that. Figure out what you missed. There's liquid somewhere. There's something going on there. All right, as can be seen here, we're still getting 17 volts on PPBush G3 Hot. So removing the corrosion is not good enough because I believe that at this point we have fried the circuit. So what we're going to do is we are going to replace both the ISL 6259 and this transistor over here. We're going to replace both as a pair, because if this is broken and I replace this being broken will kill that. Then I replace this, but I just killed that, so that's going to kill this, and so on and so forth, and it will be this never-ending back and forth. I don't like this whole thing where I'm supposed to coddle it because it's made in America, so I should have lower expectations for the device just to appreciate the fact that something's made in America. I mean, I'm not going to coddle it because it's made in America. You know, the thing is, it's expensive, it's low power, it's low tech, it's put together poorly. I'm not going to coddle a piece of machinery simply because it's made in America. You know? Like, that's the bigotry of low expectations. And don't get me wrong, I expect it to be I expect it to perform poorly if it's made in America at this point. Like, whether it's a car, a hot air station, web designer, like contractor. Every time I go for made in America, it doesn't go well for me. But is what it is. Is what it is. And we are going to remove the transistor as well as the ISL6259, and we're going to replace both of them as a unit. If you replace one and not the other, expect the customer to repeatedly come back as one kills the other over and over and over again. It's not fun wasting your time, and I would highly suggest that you not waste your time by replacing one instead of the other. Replacing one instead of replacing both. Now this is going to be really difficult to replace because it's got a really high thermal mass in this area, big transistor, and you got really tiny connectors that are going to melt right off the board right next to it. So I'm going to get as close as I can to this transistor, which is not usually my way of doing the work, because what I value here more than just about anything else is not melting everything in the surrounding area. To be clear, this would never come off in a million years with an Edison. I would never remove that transistor with an Edison. I could stay there, I could preheat the board, I could stay there all year. That thing is going to be stuck there. Alright, now I'm going to add a little bit of flux since that one of those little items beneath it was affected a little bit. I want it to reflow itself back in a place where it belongs. Now I'm going to get a new transistor. I'm going to take it off of my donor board that has a dead CPU. Mobile streams for biking and real estate, it's really difficult because the YouTube mobile experience with most the LTE providers in New York is garbage. You won't be able to see anything. Everything will be a pixel. So I can do a speed test on my phone and it'll say I have 10 or 25 megabit per second up, but then I use the YouTube app to stream, and even if it's from a flagship at the time, like when I had the Samsung S7 when that was a flagship, or the LG G8 when that was a flagship, the stream would come out as 3 or 6 pixels. And then I would do a speed test after it, even on open speed test, not just speedtest.net, where they're cooking the results at Verizon probably to make the user think they're getting more than they are, like a lot of ISPs do. And it would show me a good result. Shit. Transistor tried to jump away. Get back here. So mobile live streaming could be fun, but it's just in New York City. I don't know if it's the phone, the app, the operating system, or the ISP. But even when I was using a VPN, it was coming out like shit. So I gave up and I stopped. Okay, so we've got our transistor soldered over there. Now I'm going to replace the ISL6259 on the other side. You just make those solder joints look a little nicer. Some flux and some solder. Yeah. What bothers me is that there's several things that bother me about the Edison, and I think the biggest one is they know what I'm using it for. They know I'm using it on these boards. So you have to know when you're presenting that to me that it's going to work like crap for what I do, and you sent it anyway. And there's just kind of a lack of research that went into that that's indicative of marketing people that don't really follow or understand the industry or the people that they're reaching out to in the industry that they're in. Alright, here we go. So I think I see what's going on here. That pad on the board where the corrosion happened is actually kind of destroyed. So I'm going to have to scrape away at that a little bit. Let's see if you can see. So that is the pad that is destroyed there is going to be the second one on the top right, which is for charger phase. And we're going to do a little bit of scraping and see if we can get something back there. So just nothing crazy, just some minor scraping and rehabilitation. Remember, we don't ever want to put solder on top of corrosion. That's not what we do here. What we do is you scrape and get rid of the corrosion. You want that corrosion to be scraped off somewhere else on the board, get sucked up into your iron or your flux or whatever, and then you can solder on. You can put solder on. So I don't want to solder on top of corrosion. I really want to remove every little piece of corrosion over there, and that's what we did. QZ defines, it's hard to really say that, because so the first time I got contacted by them, it was not a letter, it was a phone call. Yeah, a phone call is not a letter. Don't think I've got a letter. Just a phone call. Mildly unhappy phone call. Okay, so we're going to take the ISL 6259 from my donor and put it there. The center pad has too much solder on it because that is my hallmark. The warranty sticker right there. I'm going to preheat this board a little bit so it's going to be accepting when I put the chip down. Okay. Now we're just going to get rid of the solder blobs. Alright, on that side, and make sure every joint is soldered the way it should be. I want those joints looking uniform and properly on the board. And that's what we got. All around, happy joints on a happy board. Probably use a little bit more HDR in this section, but oh well. Let's see what more HDR looks like. Too much HDR is weird. Alright, we're going to cool the board off for a moment. Alright, so we got a fan spin over here. Now we've replaced several things in the PP Bus G3 hot circuit. So when I measure PP Bus, you'll see that I get 8.6 volts, which is what I'm expecting. See? 8.6. That's what I want. But that's going to be able to charge a battery. Now, I'm going to plug the battery in, and we're going to see if the amperage draw goes up, if it's able to charge the battery. If the amperage draw starts to go up after I plug the battery in, then that means that we have fixed this board, and it is working, and can be given back to a happy customer. I'm just going to step away from my desk in case it decides to send 17 or 18 volts to that battery, because I'm afraid. Alright, this board usually takes 550 to 600 milliamps. By itself, the fact that it's going over an amp means it is indeed charging the battery, which means we have fixed our customer's problem, and we do have a working board. I'm hoping at this point that you learned something on how buck converters work, how these failures occur, and how you can figure out how to associate specific problems with specific areas that you should check in the future so that you understand what's going on. And don't believe that board repair can only be done by people that have a degree in electronics engineering, can only be done by people that are born geniuses, or people that you think are way smarter or more successful than you. If someone like me, as stupid as me, can do this, then so can you. But make sure that you do it right. Make sure you really seek to understand what you're doing, and make sure that you care about quality output and not just trying to get shit done as quickly as possible while you're learning so that you can make as much money as possible before you know what you're doing. Really sit there, really try to absorb what you're learning, make use of the resources that have been put up for free for people like myself and Jessa before you get into this, and start experimenting on stuff that belongs to you rather than what belongs to other people. You'll find that this is a really fun hobby after a while, and when you can actually start making money, then it gets really interesting. That's it for today, and as always, I hope you learned something. I'll see you all in the next video. Bye now.